Hey everyone, welcome back to Dev Parkour. In this video, I want to talk about SQL injection. Now, SQL injection is kind of a weird vulnerability because since I started building web applications, the divergence between front end and back end has just exploded. When I first started building web applications, there was just the web application. And when we talked about front end and back end, it was more a split between the web application, which handled business logic and the HTML generation, and the data layer, which was the database and maybe some stored procedures and that sort of thing. Now, the split is between the JavaScript that runs the UI that runs in the browser versus some API that handles storage, authentication, microservice-y stuff, that sort of thing. So SQL injection has kind of become less of a, it's less in your face than it used to be. So in my experiences with front-end engineers, lots of people don't even know what SQL injection is, which really surprised me, coming from the background that I've come from. So in this video, I want to talk about what SQL injection is. I want to show some examples, and then we're actually going to pull up the security scan of Glassminnow. If you haven't been following the channel, I've been taking a PHP application that I wrote several years ago and kind of turning it into a more modern, scalable, secure web application that hopefully might have life beyond this channel. But we're going to take a look at that and take a look at the SQL injection vulnerabilities that the security scanning tool found, which, as we'll see a little bit later, not to spoil it for you, definitely watch until the end of the video. But those SQL injection vulnerabilities that it found aren't necessarily SQL injection vulnerabilities, but they're still things that we should address. And you'll see what I mean when we get to that point. But first, let's jump over to Visual Studio Code and look at some examples of SQL injection. All right, so here we have Visual Studio Code, and let's just write what a normal SQL statement might look like. So you might have something like select star from my table where, well, let's just stop there. This is a typical select statement. It starts with the select keyword and then the list of columns to extract, and then the from keyword, and then a table to extract it from. Now, in this case, there isn't much of an opportunity for SQL injection because this is pretty standard SQL. However, if we start adding more parameters to it, we'll start to get into SQL injection territory. So let's do where, let's say my table has a name column, and we'll do something like that. Still, totally static SQL. We don't have to worry about SQL injection here. Where we do have to worry about SQL injection is if, let's say, we're writing PHP, for instance. Let's just do that, and let's say SQL equals, let me get some syntax highlighting here. There we go. Select star from my table where name equals, it's highlighting very interestingly. Not entirely sure what's going on there. But yeah, let's start with that. And let's say something like that. Right? It looks like fairly innocuous SQL, but first things first, that won't even run because the SQL that it generates is going to be select star from my table where name equals Brian. Right, no quotes around the Brian. So let's fix it. We have a couple different ways we could do that. We could do something like that. Okay, that's totally fine. Actually, those should be single quotes, shouldn't they? Yeah. So now we would get that. Another thing we could do is do this. Right? That would be a little bit safer. But what happens if I were to put something like that as my username? Let's say this came in from user input. Right? Now, the thing that would get replaced here would be, well, let's just literally copy and paste that. So now we have a perfectly valid SQL query, select star from my table where name equals empty string and 1 equals 1. Actually, this should be or, that's typically the attack, or 1 equals 1. Now this will actually, oh, and the dash dash is as a comment in SQL. Now this will actually retrieve every row in the table my table. This is a SQL injection attack. And this is bad. Now the way we defend against it is typically, well, there are a few different ways. One, you could use something like stored procedures. But the typical way to do this is to use parameterized queries, sometimes called prepared statements. Basically, where the issue arises is you have this string concatenation. When you're dealing with SQL, string concatenation, bad. Do not do string concatenation when it comes to SQL. So instead of doing this, what I should instead do is that. And again, I don't know why this is highlighting weird. This is highlighting very strangely. So now, even if this username is, this screwy thing, when we run the query, we'll just imagine that there's a query function. Depending on whether you're using MySQL or Postgres, there's different syntax for this, but it would be SQL and then probably an array of parameters. And basically what this does is it actually sends multiple statements to the SQL server. It sends a, I'm going to get this wrong, but I think it's prepare statement and then this select, and then it'll send a bunch of sets for the different variables, the different placeholders that you have here. And then it'll do, it's either execute or evaluate or something like that. Basically run this statement with those values. And you can look this up in the MySQL documentation. Or if you're not using MySQL, if you're using Postgres or something like that, look up the documentation for prepared statements. There'll be an example of how prepared statements work behind the scenes, but typically you don't have to worry about those details, because whatever library you're using, the PHP MySQL driver is no exception. Whatever library you're using takes care of that. So you typically have a some query method or something like that that takes 2 arguments. The first being the parameterized SQL statement, and the second one being an array of values or a collection of parameters. In the .NET world, there's a specific data structure. So you create a statement object. It gets command text, which is the query. And then there's a parameters collection, which is another property on that object. And you can add multiple parameters to there. For .NET, the syntax is a little bit different. They actually use named parameters, so you might do something like that. and then your array would actually be an associative array of, name to username or something like that. Either way, the semantics are still the same. You have a statement that has some parameters, and you have some values that should be used to provide the data for those parameters. And this is safer. This is, I want to say 100% safe. That you can probably find a way around it, but it would be very difficult. But this is the way to do it, because it tells the SQL engine. No, I guess it is probably 100% safe, because it tells the SQL engine this information, this username value, this right here, is data. Don't ever use it as anything other than data. Now, this doesn't prevent you from things like cross-site scripting attacks, because a script tag and JavaScript is perfectly valid data. Even this is perfectly valid data. Just don't try to use it in directly in a SQL statement. Now, a sneaky way that you can get into trouble with SQL injection is, let's say you have a stored procedure. And inside that stored procedure, you create some, I'm going to butcher MySQL syntax, but imagine this is pseudocode. Set SQL equals select star from table name, and this would actually be probably like concat, right? And in your PHP code, you might still call the stored procedure. In PHP, call my stored procedure. And if it takes data, if it takes parameters, let's just make up some function names. My call stored procedure, my stored proc. Let's say you provide parameters of username. Obviously, this will create bad SQL because it's designed to be placed in a where clause, but because you're calling a stored procedure, you don't really know where this data is going to be used. This is basically a SQL injection vulnerability, just in SQL code rather than in application code. So this is just as dangerous. Anywhere you have concatenation, string concatenation, where you're concatenating pieces together to form a whole SQL statement, you are creating a SQL injection vulnerability. So do not do it. I would say do not do it across the board. There's one exception to that, and that is if you are picking a known string from a set list of strings. So if above this you have something like table name equals some flag, and it would be users or archived users. Okay, that's acceptable. That's safe-ish. As written, that would be safe, because right now that does not leave you open to SQL injection vulnerabilities. But I would still avoid this, because you don't know if somewhere down the road you're going to potentially add some code that sets table name to something that isn't validated input. And that's just bad. I'd rather just not set myself up for that sort of potential issue. Okay, so enough talk about what SQL injection vulnerabilities are. Let's talk about how to fix them. We talked about using parameterized queries, but probably the safest way to go is to use an ORM, use an object relational mapper. And in Glassminnow, we're using PHP Active Record. Actually, my fork of PHP Active Record called Pails Active Record, which I have done some maintenance on in a couple previous videos. ORMs are really helpful, and one of the reasons that they are that helpful is because they really abstract this away. They even abstracted this away. So rather than writing out raw SQL, you can call methods and it will build the SQL in a safe way. Smart people have put together these ORMs in ways that won't leave you, the application developer, open to SQL injection vulnerabilities, so that you don't have to worry about them as much. Where you do have to worry about them is if they allow you to run arbitrary SQL. As soon as they allow you to run arbitrary SQL, all of the responsibility goes back on you to make sure that you're not opening yourself up to SQL injection vulnerabilities. And they also abstract away, whatever your database engine's query method is, or your database driver's query method is, which is why I don't remember the exact signature of this call. So, like I said, I'm using Pails Active Record. It basically allows me to just construct the where clause and strongly recommends parameterization. In Glassminnow, I have used parameterized queries all over the place. So as we'll see in a minute, the security scan didn't actually find any real SQL injection vulnerabilities, though I do perform some construction of SQL, which is something that I do want to fix. That's not going to be in this video. I'll probably do that off camera. But that is something that doesn't fill me with a sense of confidence that it isn't introducing a SQL injection vulnerability, even if the scan didn't find it. So let's actually take a look at the scan. All right, so here is the security scan that I ran on Glassminnow, and you can see it thinks it found 7 SQL injection vulnerabilities. Now, I will say I wouldn't necessarily trust that just because it only found 7 SQL injection vulnerabilities that this is all of them. I've mentioned in videos before that with 879 security issues found, it's probably found a lot of the low-hanging fruit, and some of the really nasty, sneaky issues that really, really need to be fixed probably got hidden by some of these other ones that I really should have fixed, especially reflected cross-site scripting and these 665 stored cross-site scripting issues. I really should have fixed them before I ran the security scan. So I am going to rerun the security scan in a few weeks, possibly not with this tool, depends. But at that time, we'll see if any new SQL injection vulnerabilities come up, because we are going to fix these 7 in this video. So let's take a look at one of them. We really only need to take a look at one because all of them are pretty much the same. So basically here what it's saying is that it set this application address zip value to 753 Main Street 1 having 1% 3D equals percent 3D is equals. So having 1 equals 1 dash dash. Okay, so they tried to perform a SQL injection vulnerability, and while it didn't really succeed, it did dump a stack trace, and that's what I want to fix in this video. That is not a SQL injection vulnerability, but that is an issue. So I actually want to address this. So let's figure out where this is happening in Pails. And this is in Pails code. So we'll just go over to Pails. I have it open in Visual Studio Code over here. And I'm going to search for that pre-tag, because I'm pretty sure there is only one place where that's happening. Yeah, here we go. So what's happening here is, let's see if I can find all references to this dump message. So dump, an error occurred. That's fine. Where is this happening? Oh, if the application really dies, an error occurred, okay. And if we're in production, dump an error occurred, else dump long message. Okay, this is not exactly right, because what we want to have happen is in production, we don't want that error to get lost. This is good. I must not have been running this in production mode. In fact, I was running it on a development machine. So that stack trace did get dumped out because I was running in development mode, and I shouldn't have been. When you're running security scans, you absolutely should be running as if in production. You should be running your application in its most secure configuration so that you don't get, the dumb low-hanging fruit where you then look at the code, or worse yet, look at the configuration and think, oh, obviously, I should have known better. This is a false positive. You really want to be testing the most secure configuration. So dump an error occurred. Okay, that's fine. But what I really want to have happen is I want to log the long message, right? Get message at file line get trace string, right? And actually, it looks like I'm already doing that. So we are already logging. So this application log function, if we're in development, we open standard out and we dump it. That should be fine. In production, we use error log and we dump it out. So in either case, we are logging that error that got thrown. So it looks like we're actually in good shape. So we create the long message, we log it, and then this, we can ignore this. This is for something else. If we're in production, we dump just a simple an error occurred. If we're in development, we actually dump the long message to help with debugging. So turns out there's really nothing to do here other than the next time I run the scan, I really need to run it in production mode. I need to make sure that everything is configured to be the most secure configuration so that this stack trace doesn't show up. With that, unfortunately, there's no code to write in this video, but this is exactly the code that I was going to write. So hopefully you enjoyed that. Hopefully you learned something. If you've never dealt with SQL injection before, you're very, very lucky. If you're dealing with anything built on top of a database, you absolutely will deal with SQL injection at some point in your career, unless you take steps to mitigate it. And the short version of that is make sure to use parameterized queries, use an ORM, never ever do any SQL string concatenation to build up SQL queries, and really, really, really watch your data if you have to inject some extra string into SQL statements. The one use case where I tend to see this a lot is sorting. Typically, you want to add like an order by or order by descending clause onto a SQL query. Don't do that. Hopefully, your ORM has some way of doing that, so you don't have to manually write SQL. I highly, highly, highly recommend using an ORM. Even if you use something like Dapper, which I think I did a video on recently. If you use Dapper, you do construct a SQL query, but it does support parameterization. So please, 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 please use parameterized queries to avoid SQL injection. Thanks for watching. If you haven't subscribed yet, please hit the subscribe button, click that notification bell, hit that thumbs up. If you liked the video, if you learned something, leave a comment down below if you have other questions about SQL injection, or you want to learn more, or have other ideas. If you want to see a specific topic in a future video, go ahead and leave a comment down below. I'd love to hear what you want to learn about, and I will put it on the schedule and make a video about it. Thanks for watching. Have a great day, and I will see you tomorrow.